where F is the focal length of the mirror, U is the object distance, V is the image distance. Proving it is not difficult. Then we drew out formation of images. We came to the realization that radius of curvature, which is equal to 2 times F, meaning we can rebrand this so that F will be equal to R on 2. If F is equal to R on 2, then we can substitute this into the mirror formula to be 1 on R on 2 equal to 1 on U plus 1 on V. And 1 on R on 2 is 2 on R is equal to 1 on U plus 1 on V. So this is another way of expressing the mirror formula. So when you see this, it's being expressed in this manner, it is coming from the fact that radius of curvature is twice the focal length of the mirror. Okay. Another way of expressing the mirror formula, you see, we've been talking about magnification. Magnification. When the image is formed, and the size of the image is greater than the size of the object, we say that the image is magnified. When the image is formed and the size of the image is less than the size or smaller than the size of the object, we say that the image is diminished. This magnified diminished thing is what magnification expresses. Here we term this particular magnification as linear magnification. Linear magnification, represented by small letter m. Okay. Linear magnification can be expressed in 2 different forms or aspects. We have what we call um, transverse magnification. So linear magnification is or can be expressed in 2 different forms. One, we can look at transverse magnification, and we can also discuss lateral magnification. Okay, what we mean by transverse and lateral magnification. A concave mirror, aka a concave mirror, aka class, aka hey, no one is responding. Can you hear me?
Please come again.
I said this is a concave mirror, aka
A converging mirror.
Converging mirror.
convex mirror. So and this is C. Leslie.
Mr. Aja, please, your line is breaking.
Mm, there's no problem. That my line is breaking.
Your line is also breaking at my end.
Is that yours is also breaking?
Yes, please.
It's not true. It's not breaking.
It's the same problem.
Really?
Yes, please.
Do I restart then? Because it's a network situation. Is it better now?
Yes, please, I think better.
Okay.
Please, so
So
better.
okay. All right. So when we place the object anywhere, we can get either a magnified image or diminished image. So I'm just applying ray diagram. A ray of light parallel to the axis after reflection goes through F. A ray of light passing through F after reflection must go to the principal axis. Okay. Okay. Let me use ray diagram to form a better image, which will either be magnified or diminished. So I want to use straight edge to get a proper image. So when the ray of light is parallel to this, after reflection, it must reflect and pass through F. Then when the ray of light passes through F, after reflection, the reflected ray must be parallel to the principal axis. Good. So we have image formed behind C. This image is real good. Now the objects, these are rays, so do not forget to indicate the arrows. This is image height HI, object height H naught. This is object distance, and then this is image distance. Okay. From what we have, object image size is larger than the object size. So if we want to, or if we have to express the magnification of this, we can look at the transverse magnification. Transverse magnification discusses image height ratio of image height to object height. So transverse magnification is HI on HO. Hey, Leonard, lower your. Then we can also discuss its lateral magnification. Its lateral magnification. Lateral magnification. With lateral magnification, we are looking at the image distance V. Let me write here instead. So lateral magnification is the ratio of the image distance to the object distance. And so this is equal to V on U. Okay. Now laboratory experiment and then theoretical analysis shows that both transverse magnification is equal to lateral magnification. And so HI on H naught is equal to V on U. And this is equal to what we are terming as linear magnification M, small letter m. And so linear magnification can be expressed as transverse magnification or lateral magnification. And this is what we mean by magnification. When the image is formed and it is magnified, then it means that if image formed is magnified, then linear magnification M is greater than 1. So when the magnitude of linear magnification is greater than 1, then it means the image form is magnified. If image is diminished, if image formed is diminished, then the magnitude of linear magnification must be less than 1. So if magnitude of M is less than 1, then it implies that the image form is diminished. Then if M is equal to 1, then it means that image size is equal to object size. This is what we mean by magnification. So all that I'm saying is that linear magnification can be expressed as transverse magnification or lateral magnification, because HI on H was equal to V on U. That's that word, magnification. Now, this magnification thing can be factored into the mirror formula. How do we do it? Can I clean the board or you're still writing? If you are writing, hurry up. If you are not, let me know so I can continue. Do I clean it and continue?
Yes, please.
All right. So if magnification is M is equal to V over I on H2, then F being equal to 1 over U plus 1 over V, we want to substitute M being equal to V on U into this equation. If you multiply through by v at both sides of the equation, we have v times 1 on f is equal to v times 1 on u plus v times 1 on v. This side is v on f is equal to v on u plus 1. Because the magnification is v on means that we can equally express this as m plus 1. We can also multiply 2 by u to have the same magnification formula. If we multiply this 2 by u, we have u times 1 on f equal to u times 1 on u plus u times 1 on v. So we have u on f is equal to 1 plus u on v. Now what is u on v? What is u on v? Yes, class, what is u on v? Anybody? Mamiya, what is u on v? Bedu, Gabe, what is u on v? Cadmiel, Leslie, Della, u on v is equal to the inverse of m. M magnification is equal to v on u. So if we have u on v, is the inverse of this. So 1 plus plus 1 on m. This is another different way of expressing. So the magnification can be this or can also be this. Please, is that understood?
Yes, please.
All right. So this is that with the mirror formula, magnification, and how different we can recreate the magnification, the mirror formula. Please, any question? All right. If there's no question, let's quickly continue. So apart from the mirror formula, then the magnification formula, in the mirror formula to solve problems, there are some rules which we must understand and apply. These rules goes with using the mirror formula and then yes, the magnification. These are termed conventions. So we must understand the rules and then use them with the mirror formula for solving problems. So let's quickly go through the conventions. The conventions, as I said, are rules that are used in applying the mirror formula. We have two main conventions. First, we have what we term as the R.P convention. R.P. This R.P simply means that R.P convention. R.P means real is positive. So R.P convention means real is positive convention. It implies that anything that is real must be treated as positive. Real is positive convention. Okay. Anything or any measurement that is real must be treated positive. So any measurement from the mirror, any measurement from the mirror that is positive, that is real, must be positive. Real is positive, implying that any measurement that is virtual is negative. So if anything real is positive, then it also means that anything virtual is negative. That is what this convention means. Then we have, hold on a second, I'm coming in. Let me adjust. Okay. So this is the R.P convention. Then we have N.C convention. I'll go through each one of them. N.C. This also, N.C means new Cartesian convention. New Cartesian convention. Do not be scared by the name. The Cartesian plane is your X and Y plane axis. Your X and Y axis. That's the Cartesian plane. We have Y positive. We have below. We have negative Y, negative X, and positive X. And this is something you know. So if it's about mirror, measurement start from the pole. All that is applied here is that measurement that occurs in front of the mirror. Any measurement, don't forget, measurement is always taken from the pole. Any measurement that occurs in front of the mirror is treated negative because it falls within the negative x-axis. Any measurement that occurs behind the mirror is positive because it falls within the positive x-axis. Any measurement up here is positive. Any measurement down here is negative. And this is what N.C convention means. Any measure, because we are using the Cartesian plane, any measurement in front of the mirror is treated negative. Any measurement behind the mirror is treated positive. Any measurement vertically upward and negative down there. Please, is it understood? Is it understood?
Yes, please.
Okay, so let's pick the mirrors one at a time and look at how we can apply the convention, N.C and R.P conventions to them. Okay, so we are going to pick each of the mirrors and look at how to apply R.P. If we take concave mirror, or let's respond, or everybody is fine.
Converging mirror.
So concave or converging, convex or diverging. You must use these two terms, okay, so that you master When it's not this, you can always apply. So let's see how R.P convention is applied to concave or convergent mirrors. A converging mirror has a real principal focus because paraxial rays actually converge in front of the mirror. So as for convergent or concave mirrors, F is real. It also has real center of curvature. It is also real because when rays hit the mirror perpendicularly or normally, they will all, irrespective of where the ray is coming from, they will pass through this point. So concave mirrors is also real. R is real. So because of this fact, concave mirror U is positive because object placed in front of the mirror is always real. We don't put virtual objects. How can virtual objects be placed here? And no. So objects are always real. So object distance U is always positive. Because it has a real principal focus, focal length F is positive. Radius of R is also positive because paraxial rays actually will pass here. For image distance V, it can be positive or negative depending on the nature of the image formed. So V can be positive or negative. And this depending on the nature of image formed. So for V, you need to listen to the question and then decide the kind of image that is being formed. If the image form is real, then V is positive. If the image form is virtual, V is negative. So that is the whole nitty-gritties of R.P convention. Anything real is positive, anything virtual is negative. Then let's look at N.C for concave. How the N.C convention is also applied for this. N.C is the new Cartesian convention. Basically, our old X-Y axis, which we know of. So under this convention, any measurement in front of the mirror, this is positive Y, negative Y, negative X, positive X. Under this convention, object will always be placed in front of the mirror. Focal length of focus of concave mirror is real, so it will always be in front of the mirror. So F will be here, then C, center of gravity will also be here. So under this convention, both U, U will be negative. It will be negative because they will all occur in front of the mirror. Don't forget, any measurement behind the mirror is virtual. So under NC, both U and R will be negative. What about V? The image form is real. What do you think will be the sign attached to the image distance?
So please, I'm lost.
If the come again,
I'm a bit lost.
you
Because I got cut out. So the part
don't
about
worry.
the NC and the I'm confused.
Don't worry. We'll go through it again. So we'll discuss for our converse. If the image form is real, what do you think will be the sign attached to V? Yes, class. If image is real, what will be V? Will it be positive or negative? We are sharing ideas. Please
I
don't
think
waste time.
positive.
If the image form is real, what will be V?
I think negative.
Leslie was trying to speak. I think out.
She said positive.
Under NC convention, it is just a X and Y axis. Any measurement in front of the mirror falls within the negative X axis. Any measurement behind the mirror falls within the positive X, positive Y, negative Y. So if the image form is real, what do you think will be the sign for V? Will it be positive or negative?
I think this will be negative.
Clearly, it will be negative because real images in mirrors will always be in front of the mirror. Virtual images will always be behind the mirror. So if image is real, V is negative. If real. If image is virtual, what will be V? Sign to V. Leonard, if image is virtual, what will be the sign that must be attached to V? Leonard, I hate this time wasting.
Please,
Mommy,
positive.
positive. So positive if image is virtual. So that's the whole thing. It's not difficult at all. You just need to understand how the rules, okay, RP and then RNC convention is about and apply them. Let's pick for convex or divergent mirrors and see how we can apply RP and NC convention to it. So we've just done it for convex or concave or convergent mirrors. So this is convex mirror. And we are applying the RP convention. That must always be placed in front of the mirror. So it is always real. So for convex, what do you think will be a sign that will be attached to you? Would you be positive or negative? Would you be positive or negative? Let's not waste time, please. Just express your view. would you be positive or negative? RP.
Positive.
Pardon?
Please positive.
Gabriel. Object is always real. So if you are using RP convention, because object is always real, you would be positive. What about F? Would F be positive or negative? Gabby, your hand is up.
Yes, does it mean that no matter where the object is, since it's a real object, you always be positive?
Yeah, for RP convention.
Okay.
Okay. And don't forget, object is always placed in front of the mirror. Okay. Because when you place the object behind the mirror, there wouldn't be any image form because the other side, that side is coated. Okay. So because object is always real, for RP, you would be positive. What about F? For convex, what about F? Would F be positive or negative?
F will be negative
Mamiya, why will it be negative?
because the focal point is behind the mirror.
Good. Convex mirror has a virtual principal focus or focal point. So because for convex, focal point is virtual, it will be areas of curvature. Will it be positive or negative? What about R? Will it be positive or negative? I have 23 of you in class now. So let me hear your voice. Della, I don't like your silence. Eva, I don't like your silence. What will be R? Anybody? You are wasting my time. Gabby,
I'm not sure, but I think positive.
in fact, the attempt, I'm okay with it. But why do you think it is positive? Gabby, why do you think it will be positive? Is there any reason?
I'm not sure if my reason is correct,
But just, we are
because
learning, so try.
because the object is real.
We are talking. Gabby, what is R? What is R? R is the radius of curvature, the distance from the pole of the mirror to the center of curvature. Okay, the distance from the pole to the center of curvature. So it means that convex mirror has a virtual. Okay, I'll go over. Don't worry. Convex mirror has a virtual principal center of curvature. When light hits the mirror at 90, it, it reflects along the same path and appears to through a point behind
Your
the
line
mirror.
is breaking.
Okay,
Joel, breaking.
breaking bay is not. So this one has a virtual center of curvature C. So is the principal focus or focal point. It is also virtual. So the distance from the pole to the center of curvature, which we are calling as R, is virtual. It It is the same as the principal focus. And because R occurs behind the mirror, R will be negative. R will be negative. Gabby.
Let's say if R occurs in front of the mirror, that means it's positive.
Yes. If R would occur in front, okay, as if C would occur in front, R will be positive. But for convex mirror, there's no way R will ever be in front. It is always behind the mirror, like the principal focus or the focal point. Go back, when we finish, go back to your notes and look at all that we said about concave and convex. Are you okay? Gabriel, are you okay?
Yes, sir.
Now, Gabriel, I put this question to you. What about V? What do you think will be V? Would V be positive or negative? Don't forget we are using RP convention. Joel, mute yourself. Joel. Gabby, would V be positive or negative? The moment you delay, then it means you have forgotten the basics we learned under convex and concave. Class, for convex and with RP, would V be positive or negative? Mamiya,
I think Z would be
Mamiya,
negative.
speak boldly. Speak boldly.
V is negative
Why? Why do you think V is negative?
because in convex mirrors, no matter where you place the object, the image will always be virtual and should be from behind the mirror.
Exactly. Exactly. That is the point. So, Gabriel, V will be negative because for convex mirror, no matter where you place the object, the image form is always virtual.
Okay, sir.
So it is for this reason that when you are using RP for convex, V will be negative because it's no matter where the object is placed, it will form a virtual image. So RP means real is positive. Anything real is positive, and anything virtual is negative. That is all. Let's apply um to convex. NC. So we are discussing it. And when we finish, we will use them to solve problems. Then you would understand. Okay. But class, there is a need of you to contribute. Do not keep quiet. Getting it wrong is part of the learning. So no, do not be shy of getting something wrong. Just express your views. Angel is always quiet. What kind of angel is that? An angel who is quiet always. As for the law, I won't even say anything. I think I'll just call your father. Express your views, okay? You say it and get it wrong, and be giving explanation to. That is what is important. NC is the x-y-axis. So we have positive x, negative x, positive y, negative y, NC. Any measurement for NC, any measurement in front of the mirror is negative. Any measurement behind the mirror is positive. Okay. So NC, what do you think will be you? Would you be positive or negative? This is convex mirror. Would you be positive or negative, class? Gabriel,
Negative.
negative, because objects will always be placed in front of the mirror. Would F be positive or negative? Caleb, would F be positive or negative?
F will be negative.
Why would it be negative? Caleb, what do you think that would be negative?
F would be positive.
F will
F
be
would rather be
positive.
positive.
Why? Why will it be
F would rather be
positive?
positive, sorry.
Yes, so
Because it
why?
is traced to the right side of the mirror. So it will be positive.
Good. Or and always has a
Because it is on the
virtual,
right side of the mirror.
yes, virtual principal focus. The focal point or the principal focus is always behind the mirror. So F will be positive. Would R be positive or negative? Angel. Nana Joa. People are quiet too. Gabriel, would R be positive or negative? Gabby,
Yes, sir.
would R be positive or negative?
Negative.
Can you say your reasons with me as why R will be negative?
If the center of curvature comes behind the mirror, then R will be negative. But if it comes in front of the mirror, R will be positive.
Gabby, you are still lost. Leslie,
Yes, please.
will R be positive or negative?
Please, I will be positive.
Why?
It is positive because it is virtual and it is behind the mirror.
So that give another point. The radius, the F, the R convex mirror is always virtual. It is formed behind the mirror. And once it's formed behind the mirror, it always comes here to the right hand side. When it is at the right hand side, measurements will be taken from P to X. So R must be positive. What about V? Gabriel again. Would V be positive or negative?
Sir, please, what is it, a convex mirror or concave?
Gabriel, I'll tell you, but You don't need to ask to know. I've drawn it. And this side is the shaded part. Once it is shaded, you must know what kind of mirror this is. So
Yes, please
Gabriel,
be negative.
what be positive or negative?
Negative because any image formed in a convex mirror is always virtual.
Yes, what you are saying is completely right. The image formed irrespective of the object position is virtual. If the image formed by this is always virtual, will it be formed in front or behind the mirror? They are putting you to spot, and it's a very good exercise. If you are saying that any image formed by this is virtual, will it be formed in front or behind the mirror? Gabby,
In front.
again, speak, go ahead. Will it be
In
in front or behind?
in front.
Okay, listen. Oh, class, listen. I've been saying it and I'll say it again. All images formed in mirrors, whether spherical or if the image formed is in front of the mirror, it is real. If the image form is behind the mirror, it is virtual for mirrors. So if the image is virtual, then it will be formed behind the mirror. So V must be positive. It's not easy. Oh. So this is the nitty-gritties of NC and RP convention. I'll pick a question, then use both conventions to solve it. Then you can understand the application of the convention. Okay. So let me give you a quick question. I'm reading out to you a question. Then we'll see how to apply NC. Okay, so a concave mirror has a radius of curvature of 24 centimeter. A concave mirror has a radius of curvature of 24 centimeter. How far is an object from the mirror? How far is an object from the mirror? If an image is formed, that is, how far is an object from the mirror? If an image is formed, that is A, virtual, and 3 times the size of the object.
Again, please. My line was breaking, so I couldn't hear it.
Let me send a shot. Let me send a quick shot, okay? Okay, so question same. So a concave mirror has a radius of curvature of 24 centimeters. How far is an object from the mirror if an image is formed that is A, virtual and 3 times the size of the object, B, real and 3 times the size of the object, and C, real and 1/3 the size of the object? You see, the question never stated the convention to use. So here what it means is that you are free to use any of the conventions you understand in solving the problem. Okay, you are free to use any of the conventions you are so comfortable with to solving the problem. Okay, so we are going to use both RP and NC conventions to solve the problem. All right. So let's see how we can apply the conventions in dealing with the problem. So the question says that a concave mirror has a radius of curvature of 24 centimeters. So R is equal to 24 centimeters. How far is an object from the mirror if the image is formed that is A, virtual? So the A question says that if the image is virtual and linear magnification is 3 times the size of, of. So all that the question demands is that we are to determine how far is an object from the mirror. So we are looking for object distance. Okay. Now, in solving the problem, you need to understand the kind of mirror that is being talked about. What kind of mirror is being talked about here? We are told it's a concave mirror. That is very, very important. We are dealing with concave mirror. So if it's concave mirror, then you know that for P, using real is positive convention, concave mirror, F is positive because F is real. R is also positive because C is real. Okay. Then V, for V, you need to understand the kind of image you are told to be formed. We are told that if the image form is virtual and 3 times the size of the object, it clearly means that V will be negative. Plus, I hope you are okay. Hello, are we okay with what we've extracted so far?
Yes, please.
So, the next thing to use is R is 24. You know R is equal to 2 times F. So if R is 24, then F is equal to 12 centimeters. So substitute your values. 1 on 12 is equal to 1 on U. U is positive. Plus 1 on. We don't have it, but we are given a clue. We are told that the image is 3 times. So it means magnification is equal to 3. Linear magnification is equal to 3. And we know linear magnification M to be equal to image distance over object distance. Therefore, when we make V the subject, V is equal to 3 times U because M is 3. So V is equal to 3U. So 1 on U plus 1 on V is virtual negative. So minus 3U is equal to 1 on U minus 1 on 3U. Please, is it understood up to this stage? Class, is it clear up to this stage?
Yes.
So go ahead and solve 1 on 12. 1 on 12 is equal to 1 on U minus 1 on 3U. So solve for U in a particular equation for me. I'm waiting for you. Whilst I take care of attendance. Yes, Caleb. Caleb, go ahead. Your hand is up.
So please, I found U to be 16 centimeters or 0 centimeters.
So you had 16 or 0.
Yes, please.
Okay, let's have a seconder. Let's have a seconder.
I am still confused.
Oh, somebody.
Oh, somebody to second.
This
Your attitude of time wasting. Yeah, I'm not happy with it at all. Second, tell us whatever you've had. That's all that I want to know. Yes, Caleb. Gabby, go ahead.
I got 2. U to be equal to 2 centimeters.
U to be equal to 2.
Yes, please.
Okay. I'm coming. So I'm coming. So 1 on 12 is what we do.
Please,
We
I
are
got
solving
8.
this. You said you got what?
8.
8. 3U. U goes into LCM 1, remainder 3. The remainder times 1, yeah, 3 minus. Gabby, mute yourself. 3U goes into the LCM 1 times that. So we have 1 on 12 is equal to 2 on 3u. 3u is equal to 12 by 2. Therefore, when you divide 2 by 3, that's 4, so 8 centimeters. So if the image is 3 times magnified, then the object distance will be 8 centimeters. We'll check if it makes sense, but we want to use NC to solve the same question, also to compare whatever we can have. NC is a concave mirror. Once it's a concave mirror, object is in front of the mirror, so U is negative. Concave mirror has a real principal focus and it occurs in front of the mirror. F is negative. R is also negative. Image, we are told, is virtual. So V will be equal to positive. Image is virtual, meaning it occurs behind the mirror. So using, if R is 24, that will be negative 12. Or negative 24, F will be negative 12. So that using the mirror F equals 1 on U plus 1 on V. We have minus 1 on 12. Or 1 divided by negative 12 is the same as this. This is equal to minus 1 on U. U is negative. M linear magnification is V on U. S is 3. Therefore, V would be equal to 3U. So we have plus 1 on 3U. Because V is positive. Okay, it's behind the mirror. So when we rearrange this, we have 1 on 3U minus 1 on U. If we want to put a positive before the negative. This will be 1 minus 2. Sorry, minus 3. When we subtract, we have negative minus 12 is equal to minus 2 over 3U. The minus will cancel out and we will have the same thing as we had. 3U will be equal to 12 by 3. 12 by 2. Therefore, U would be equal to 12 by 2 divided by 3, which will still be equal to 8 centimeters. The same answer as the RP gave us. So whether RP or NC convention, the value is the same for object distance. Now Let's use the theory to test whether our answer is reasonable or it makes sense. We have a concave mirror. Object distance, focal length 12. Radius of curvature 24. So this is the distance from the pole to Earth. We are told is 12. Object distance is 8. Centimeters. So if you have an object placed between the pole and then Earth, what kind of image will be formed? And we've learned this. If the object is between the pole and Earth, the image form is virtual. Image form is magnified. And that is all that we are given. We are told that the image is virtual and 3 times magnified. So it implies that the object must be placed between P and F. So meaning our answer is correct or makes sense. Class, is it understood? Hello, is it understood?
Yes, please.
It's not difficult. It's just not difficult. So personally, I'm a bit surprised you are not, you are quiet and all that. So attempt the B. The B says the same preamble, but this time B says that if image form is real and 3 times the size of the object. So start work. For B, if image is real and 3 times the size of the object. When you finish, use this to analyze whether your answer is sensible or crazyable. Start work. Okay, so I think it's the second question is 16 centimeters. So we are told the image is real and 3.0 times the object. So using the same thing, it is still real. So using RP, the length is still concave. F will be equal to plus 12 centimeters. Object is positive. It's real object, so you will be positive. Then V, image is real. Once image is real, V is positive. So 3U. Therefore, 1 on F, which is 1 on U plus 1 on V. 1 on 12 is equal to 1 on U plus 1 on 3U. CM 3U. This is 3 plus 1. 1 on 12. So we have 3U equals 12 by 4. Divide 2 by 3, divide 2 by 3, and you have U equal to 16 centimeters. Who else has successfully used the NC convention? Leslie, what did you make for NC?
Please, I had 16 centimeters.
That's it. So you need to get the same results. So using NC, if I use the who doesn't talk, Mami, yeah,
Please, when you're
Mami, yeah,
solving these types of questions, do you need to show the type of convention you use,
no,
or the examiner will
no,
know?
you don't need to. You can. Okay, the most important thing is that use one of them. The
Okay.
question never stated which one to use. So use one of them. And usually the RP is simpler. Gabby,
Yeah, and please, I don't get this page. After 1 over 12 is equal to 1 over u plus 1 over 3u. Then came to 1 over 12 is equal to 3 plus 1 over 3u.
mm-hmm.
Yet that side going is a bit okay.
Oh, yeah, I'm only mathematics. So I'm solving to determine u. So what's the LCM? You have this two denominator. What's the LCM of u and 3u? Gabby, that is 3u.
3u.
Yeah. So this denominator, how many times does it go into the LCM? 1, remainder 3. So the remainder 3 times the numerator 3 plus this goes into it 1. 1 times this 1. The reason for which I had 4 on 3u. So over here, I'm just applying maths to find my u. Okay.
Okay, sir.
All right. So NC, u is negative. F is negative 12. V, I'm told image is real. So V will be equal to minus 3 because image is real. Once image is real, it will come in front of the mirror. So image distance will be measured from B will be here. So image distance B will be here in front of the mirror. So B will be negative. So when you substitute minus 1 on 12 is equal to minus 1 on U minus 1 on 3U. On the right hand side, I can factorize out negative. So I have 1 on U plus 1 on 3U. And the minuses will cancel out. And so to just come back to this part, what we were dealing with here. So basically, you have U in equal to the same thing. That's the whole thing. Okay, so I want you to begin the third question, which says if image formed is real and 1/3 the size of the object. And note this. This time the linear magnification is 1/3. And 1/3 is less than 1. It means now, okay, before we look at this, I ask you to calculate to see if it makes sense. Use the Venn diagram. See if your answer actually makes sense. So let's do it for V is equal to 16. F is 12. Okay. Meaning this is C. C is 24. R is 24. The object distance is 16, meaning object is between C and F. If object is between C and F, what kind of image will be formed? Okay, a real image. What we okay? So we had U to be 16. If U is 16, V is something 3 times 3U. 3 times 16. And what is 3 times 16? 48 centimeter. So the image will be formed behind C because this is 24. If V is 48, okay, and so that's it. It fits, the value fits the ray diagram perfectly. All right, so start with C. If image is formed that is real and 1/3 the size of the object. So meaning image is diminished. Let's see what you get for the object distance. Then we test to see if the value makes sense. Leonard, are you there? Leonard. Oh, Leonard is not there. So you are looking at it for CO. If image is magnification is 1/3. Okay, Leonard noted.
Recording, and no one was saying it. In fact, this is your culture of silence during class. Oh, no, no, no. It will not help. Very, very bad if you don't know. Okay, I'm sending you an example. I'm sending you an example to try your hands on. But when the question is given, please think through it well. It may look very simple, but can also. So listen to this question. An object is 30 centimeters from a spherical mirror. An object is 30 centimeters from a spherical mirror along the central axis, along the principal axis. Oh, that's what they mean by central axis. Yes, spherical mirror. We haven't mentioned whether it's concave or convex, but the information is that an object is 30 centimeters from a spherical mirror along the central axis. The absolute value of the lateral magnification is half, 1/2. The absolute value of lateral magnification is half. Lateral magnification is equal to transverse magnification, is also equal to linear magnification. So the absolute value of lateral magnification is half. The image, I won't even give you the nature of the image form because you must know. Okay, let me give it to you, else you'll be confused. The image produced is inverted. The image produced is inverted. What is Mamiya?
Can we get a snapshot of the question?
Why? Why do you want a snapshot?
Because I didn't get everything that you said.
What is the focal length of the mirror? I'll send a snapshot.
Thank you.
We are doing it now, so it's not an assignment. This is something we are doing here. So I'm sending a snapshot. So a concave an object 30 centimeter from a spherical mirror. So an object 30 centimeter from a spherical mirror means that the object distance is 30 centimeter. The absolute value of lateral magnification is half. Lateral magnification is equal to transverse magnification, and they are all equal to linear magnification. So absolute value, meaning we are not looking at the sign attached to it, is half. Meaning once this is m is equal to half, it means the image is diminished. And you are told the image produced is inverted. Image is inverted. So Gabby, if you are given all these details, that magnification is half, image is diminished, and image produced is inverted. Gabby, what kind of mirror is this?
Please come again.
If you are told that the image form is diminished, the image is inverted, what kind of mirror produces such an image? Or what kind of mirror would produce an image of these characteristics? Because if you understand it, then you are good to go. You see, the question said just spherical mirror. Then the kind of mirror wasn't clearly stated. All that you are told is that image is diminished, image is inverted. So, Gabriel, what kind of mirror is this?
I think the convex mirror.
I speak up.
Convex.
What's your reason? You must have a reason for choosing convex. What's the reason? Whether concave or convex, I'm very so much particular with the reason. What's the reason?
The reflecting surface is curved outward.
But what shows? Not there is no information in the question which shows that the reflecting surface of the mirror curves outwardly. Okay, let me pick somebody else's view. Yes, I saw a hand up. Please raise the hand again. Let me see you. And be ready with your reasons. Mamiya, what kind of spherical mirror forms this image?
A concave mirror.
Mamiya, you are saying two things.
Concave.
Why?
Because the image is inverted, which means that it is real. And there are two types of mirror. The only type of mirror that can produce a real mirror, a real image, is the concave mirror.
Good. So, Gabby and the rest of you, you see, if this is omitted, if this wasn't stated, but just this is not enough, because both mirrors forms diminished images that are diminished, both whether concave or convex forms it. But the question goes on to say that image is inverted. When image is inverted, it means the image is always real. All real images are inverted. And convex doesn't form real images, no matter the object's position. Okay, convex mirror always forms virtual images, no matter the object position. So once, and real virtual images are upright or erect. So once the image is inverted, then it is real, and it is only concave or convergent mirrors that forms real images. Gabby, are you okay?
Yes, sir.
Please, I entreat all of you to spend time today to go over lights, all that we've done, because we are combining everything here. Review it and then come back to this. Okay. So it's a concave mirror. And once it's a concave mirror, if you are using RP, F is positive. Okay. U is positive. V depends on the image. You are told image is real, and so V would be positive. We are looking for the focal length, but linear magnification is V on U. This is half. Therefore, V will be equal to half U. And so 1 on F would be equal to 1 on U plus 1 on V. This is V. So 2U. And U is 30 centimeter. So we can even pick it from here. Then V will be equal to half of 30, which is 15. Therefore, 1 on F is equal to 1 on 30 plus 1 on 15. LCM 30. 1 plus 2. So we have F being equal to 30 on 3. Focal length 10 centimeter. Check if it makes sense. Let's check if this value makes sense. If focal length is 10, then radius of curvature will be 20. If object distance is 30, then it means object is behind C, and a virtual diminished image will be formed. If you use NC, the value will still be the same. So on this note, I think it's exactly 9 o'clock. If you have any question, ask. If you don't have a question, your assignment as usual will come. Please do well and answer it. Okay, try it and then. All right, so this is why I draw the curtains on our meeting today. Thanks for your time, contribution, your silence, and everything. We'll have another wonderful session on Friday. Until then, may the good Lord be with you. Bye-bye.
Bye.